In this video, using the differential equations, we will determine the national income equilibrium, and it will be numeric in nature. So let's get started with the given information. We are considering a two-sector economy, and we are going to use the structural equations. The first one is a differential equation because it contains the derivative term, and it has those relevant variables, that is y, I, and c, that is national income, investment, and consumption. And in addition to this, we have the cost consumption function, which is equal to this, and finally we have the value of autonomous investment. So these structural equations will help us to develop the framework for determining the national income. We are also informed that the initial condition of the equilibrium is 7,000 units. So let's get started with the solution. Primarily, we know that there is a quite clear sign that we should continue with y and t, because we know that we are trying to find out the equilibrium level of national income. So we should not retain consumption and investment functions, so we are going to substitute them in their symbol places. So here and here we have substituted these values, and now after little bit of simple algebra, we are able to rearrange this first order differential equation in a way which is going to allow us to have small a and small b, that is the constant coefficient and constant term in the first order differential equation. So this is the information that we have: the initial condition, the value of a and value of b, and the change in the symbols of the variables. Starting with the value of b, it is a non-zero value, which is actually 500, so it's a non-homogeneous case. And a is -1 and a is not equal to 0, so we have a is 0.1 and it's definitely not equal to 0, so it's a non-homogeneous case where a is not equal to 0. So this is the equation that we can use, the formula of the definite solution of the first order differential equation with a non-homogeneous case where a is not equal to 0. So we are going to substitute those values a and b, and again these values, they have been chalked out as they are being substituted. So after the substitution of these values, we get this set of steps which we can do easily because this is the simple algebra, and finally we get the time path of the national income. Here you can see that this is the part which is the complementary function, and this is the particular integral which is the equilibrium. Now the complementary function is there, which is the deviation, and this is the time path. We know that deviation when added into equilibrium will give us the overall time path. So we are going to use the values of time, that is starting from 0, and here we are taking quite a bit of gap because we anticipated that the change in the values will be slow, so we had to take a little bit of jumps. However, we should also take the remaining values that are in between these values. To save time, we have done this, and our finding is that the value of the deviation is declining as it started from 2000 and it is reaching close to 0. So the deviation is decreasing, and definitely it is a good sign for convergence. So we should introduce this deviation in the time path equation, that is the yp, the particular integral. So 5000 was being added, and then when we added it, we found that the value was declining from 7000 to 5000, and we know that 5000 is actually close to is the equilibrium, and this value, which is very much close to 5000, is a sign of convergence. So the first thing that we notice is that the positive deviation decayed over time as the time went on. The complementary function, that is the deviation, it declined, and time path slides and converges to equilibrium, that is this. yc is equal to 0 and yt converges to this. As we can see, this is the equilibrium and this is the initial condition. This is again the equilibrium. You can see that deviation between the time path and the equilibrium is declining as we go ahead in time. This is the equation of the time path. So the convergence is imminent in this case, and this is the finding of our analysis, that we can determine the level of national income. And this is not the only thing. We can also see that how it changes over time, and also if the dynamic equilibrium is stable or not, which in this case is found to be stable. Thank you.